Hello everyone. In this lesson, we're going to be covering a very important topic, the slope of a linear equation. I find the easiest way to think of slope is the rate of change of the y values of a line over the rate of change of the x values, or change in y over change in x. Let's think about this graphically. If a line has a very small slope, we would expect that for every x unit moved to the side, we would not move many y units up. So the line would look something like this, if it has a small slope. On the other hand, a line with a steep slope, something where the change in y is much greater than the change in x, so for every 1 unit we move to the side, say we move 5 units up, the line would look something like this, much steeper. Now, we have a lot of different kinds of lines, like this, and they have different kinds of slopes. So let's look at some possible slopes. We have our positive slope. These two lines are examples of positive slopes. A positive slope happens when either both the change in y and change in x are positive over positive makes a positive slope, or both the change in y and change in x are negative, because negative divided by negative makes a positive. On the other hand, a negative slope, such as the green line here, happens when either one of the change in y or the change in x is negative. So we could have a negative change in y over a positive change in x, or a positive change in y over a negative change in x. This line actually is both. It just depends on which direction you look at it. If we look from left to right, we see that the y value is decreasing. That's a negative change in y, while the x value is increasing. But if we look from right to left, we see the x value decreasing, while the y value is increasing. The point is that they're the opposite of each other. Negative and positive, negative and positive. But there are two other important kinds of slopes. What happens when you have a line that is perfectly parallel to the x-axis? Parallel here means that even if we look at infinity in both directions, these two lines will never meet. They will run along each other forever, never touch. This line has zero slope because, remember, slope is change in y over change in x, and our change in y here is 0 because at every point on the line we have the same y value. So 0 over change in x, whatever the change in x is 0. So this is a 0 slope. Another kind of slope we can see when a line is parallel to the y-axis. This will be our y-axis. Let's see, what is change in y over change in x here? At every point in the line, we have changing y values, but the very same x value. So change in x is 0. What happens when we try to divide by 0? It's undefined. So here we say that the slope of the line is undefined when a line is parallel to the y-axis. Note that these two lines are perpendicular to each other. That's exactly the opposite of parallel. They intersect at a 90-degree angle there, and their slopes are the negative reciprocals of each other. Let's look at this with an example. Remember, parallel lines have the same slope as each other. So if we take these as lines 1, 2, and 3, the slope of line 2 would be equal to the slope of line 3, because they are parallel. Perpendicular lines, on the other hand, intersect at a 90-degree angle, and their slopes form negative reciprocals. That means that the slope of line 1, let's take that as m1, times the slope of line 2, m2, is equal to negative 1, or m1 is equal to negative 1 over m2. And here m2 is equal to m3. So a quick recap of what we did in this lesson. We went over what is slope, the rate of change of a line. We went over different kinds of slopes, positive, negative, positive, negative, zero, and undefined. And then we looked at the slopes of parallel and perpendicular lines. See you next time.